The early 1980s marked a pivotal crossroads for the American automotive industry. The aftershocks of the oil crisis still reverberated, fundamentally altering consumer expectations, while the rising tide of sophisticated European luxury and increasingly reliable Japanese engineering began to erode Detroit's traditional dominance. Cadillac, a name long synonymous with opulence and sheer scale, found itself at a critical juncture. The path forward, they believed, wasn't merely in larger engines or more chrome, but in an audacious leap into the digital age. Their ambition was clear: to redefine American luxury not through brute force, but through an unprecedented integration of cutting edge electronics and advanced automation. This vision proved compelling: a luxury automobile that transcended simple transportation, designed to anticipate driver needs, actively assist in navigation and control, and communicate seamlessly with its occupants. It served as a bold declaration, an attempt to push the very boundaries of what a car could intelligently be, heralding a future where silicon chips, not cubic inches, would dictate the ultimate driving experience. Executing this shift toward a digital automotive landscape demanded immense engineering prowess. General Motors, with Cadillac at the vanguard, poured resources into an extensive program to develop highly sophisticated electronic control units and intricate multiplexed wiring networks. Such innovations sought to replace bulky traditional harnesses with lighter, more efficient digital data streams, streamlining vehicle architecture and diagnostics. Management maintained a firm belief that digital technology embodied the future of luxury, promising unparalleled convenience, enhanced safety, and an undeniable image of technological superiority. These concepts materialized through key technological pillars: the pioneering Computer Command Control, or C4, engine management system, striking new digital instrumentation, replacing analog gauges, and early attempts at integrated vehicle networks designed for fluid communication between disparate vehicle systems. The embodiment of this forward-thinking strategy was perhaps most vividly expressed within the Cadillac cabin itself. Gone were the familiar dials and needles, replaced by a mesmerizing array of glowing digits and bar graphs illuminated by vacuum fluorescent displays. This radical departure from analog gauges aimed to project an image of undeniable modernity and precision. Beyond mere instrumentation, the revolution continued. Cadillac introduced voice synthesis systems, a disembodied voice alerting drivers to low fuel or an open door, adding a futuristic, if sometimes startling, layer of interaction. Sophisticated trip computers offered real-time fuel economy and estimated range, while memory seats and fully automatic climate control systems brought unprecedented levels of personalization and comfort. The ambition to consolidate control led to novel, if sometimes perplexing, user interface designs. Engineers explored physical buttons alongside early touch-sensitive panels, attempting to streamline the increasing complexity of vehicle functions. While the intent was to simplify operation, these nascent infotainment concepts occasionally introduced new layers of navigational challenge, demanding a different kind of driver engagement than the traditional physical controls they replaced. However, as these intricate electronic systems proliferated, a fundamental flaw began to surface. The early microprocessors of the era were inherently fragile, susceptible to heat, vibration, and power fluctuations. Moreover, the sheer volume of individual electronic components, each a potential point of failure, was staggering. Connectors degraded, solder joints cracked, and the miles of wiring harnesses, often routed through hostile underdash environments, became brittle and shorted. This cascade of potential failures created a sharp paradox. Though designed for unparalleled convenience and luxury, their inherent unreliability often delivered the exact opposite: frustrating, unpredictable behavior. Diagnosing these intermittent electrical gremlins was a mechanic's nightmare, demanding specialized tools and an understanding that few service technicians possessed. The resultant repair bills frequently negated any perceived value, eroding owner confidence and tarnishing the very image of technological superiority Cadillac had so carefully cultivated. Initially, the public had marveled at the promise of these technologically advanced vehicles, seeing them as a glimpse into the automotive future. Soon, this fascination soured. Disillusionment grew among owners as these sophisticated systems proved increasingly temperamental, leading to unexpected breakdowns and baffling malfunctions that simply defied easy explanation. Meanwhile, across the Atlantic, European luxury manufacturers like Mercedes-Benz and BMW adopted a more measured approach. They prioritized robust mechanical engineering and integrated electronics with greater caution, focusing on proven reliability over bleeding-edge complexity. Subsequently, the arrival of Lexus would further underscore this philosophy, setting new benchmarks for trouble-free operation and meticulous quality control. For dealership service departments, these cars became a formidable challenge. Pinpointing the root cause of an electronic issue often required extensive, time-consuming diagnostics that few technicians were adequately equipped to handle, pushing labor costs skyward and leaving vehicles languishing for weeks. The brand's reputation for innovation began to buckle under the weight of this operational reality, sending a clear message from the market. The immediate consequence of this technological overreach was a severe blow to Cadillac's esteemed reputation for quality. What had once been a symbol of American luxury and engineering prowess began to be viewed through the lens of unreliability, directly eroding sales figures and, more critically, alienating a loyal customer base built over decades. Such market feedback compelled General Motors to initiate a significant course correction. Gradually, the more ambitious, less robust electronic features were either scaled back or entirely phased out, replaced by systems built upon more thoroughly validated and resilient architectures. This wasn't merely a tactical retreat, it was a fundamental reevaluation. The long-term impact forced Cadillac, and indeed GM as a whole, to reprioritize their approach to integrating advanced electronics. Management decisively shifted the focus from mere technological spectacle to an unwavering commitment to reliability, durability, and intuitive user experience. That era became a stark, if costly, lesson in the vital balance between innovation and dependable execution, profoundly shaping their future product development cycles, while the immediate commercial outcomes were undeniably challenging. The efforts of Cadillac in the 1980s were far from a complete loss. In hindsight, these ambitious ventures served as an invaluable, albeit expensive, crucible for the entire automotive industry. They weren't just a series of missteps, they were foundational experiments. Engineers of that era, grappling with the nascent stages of digital integration, inadvertently laid much of the groundwork for the sophisticated electronic architectures we now take for granted. A primary lesson emerged. True innovation demands not just a grand vision, but also robust engineering, exhaustive testing protocols, and, crucially, an intuitive, user-centric interface design. This period illuminated the paramount importance of reliability over sheer novelty. We can trace a direct evolutionary line from those early talking cars and digital dashboards to the voice-activated assistants and seamless touchscreen infotainment systems dominating modern vehicles. Such early pioneers in their struggle charted the course for the digital cockpit of today. The enduring allure of progress, exemplified by Cadillac's audacious pursuit of a fully digital experience, remains a powerful testament to the automotive industry's relentless quest for advancement. Even with the acknowledged stumbling blocks, this era vividly illustrates that the journey itself, with its trials and errors, is often as significant as the destination. True luxury, we've learned, isn't merely about cramming in every conceivable piece of technology. Rather, it's found in the seamless, utterly reliable functionality that enhances, not hinders, the driving experience. These ambitious forays into digital integration, though sometimes commercially challenging, were never truly failures. Instead, they acted as an indispensable proving ground. Every glitch, every frustrated customer, provided vital data points, shaping the very foundation of modern automotive electronics. The hidden history of these bold experiments, both the celebrated successes and the difficult lessons, continues to resonate, influencing the design philosophies, engineering priorities, and user expectations of the vehicles we encounter on the road today. They were the essential, if sometimes painful, steps toward the sophisticated, connected driving environments of the 21st century.